Okay, so periodic table notes. You need these notes, and then you need your large periodic table, so that way we can go over this together. If I end up going too fast, please make sure that you pause the video so that way you can go at this at your leisure. Okay, so remember that Mendeleev was first arranged the elements into 7 groups by increasing atomic mass. Later on, about 80 years later, Henry Moseley came around and arranged it by increasing atomic number. This is what we use today. This will be a test question. Remember, periods go left to right, or the rows, and we also call those energy levels. So rows, energy levels. Okay, and then we also have groups or families, and those are the columns. There are 18 groups or families. Okay, all right. Remember, the easiest way to remember this is we end a sentence with a period, so we can help us to remember that rows periods are in rows, and then families, we think of family trees, and trees go upright, so that will be a column. Okay, metals. 75% of all known elements are metals. They are left of the zigzag line. Aluminum is the most abundant metal on Earth. So, as we move away from this zigzag line, our metals become more malleable, ductile. They increase in their thermal and electrical conductivity. They are solid at room temperature. They have a positive charge, meaning they lose electrons. That's called a cation. They are shiny or have luster. Now, as we move to the right of this staircase or zigzag line, these are our nonmetals. They're found as a solid, liquid, and or gas at room temperature. They are brittle, non-conductors. They have a very low melting point, and they gain electrons. We call those anions, and they have a negative charge. Remember, metalloids are characteristics of both a metal and a nonmetal, and those are the ones that border the zigzag line, with the exception of aluminum. Okay, so let's talk about valence electrons. Valence electrons represent the outermost electron and determines bonding characteristics. Remember, electrons have the negative charge. Alright, we have an A above the main group elements, and that A tells me the valence electron. A above each family has a number next to it. That's the valence electron. The range is 1 to 8 for these main group or representative elements. Less than 4 is a positive charge. More than 4 is a negative charge or a nonmetal. If it's 4, we have to look, is it above the zigzag line or below the zigzag line to determine if it's a metal or a nonmetal. Alright, if it's a positive charge, it gives away electrons, and it's a cation. If it's a negative charge, it needs electrons, and it's known as the anion. So a hydrogen. A hydrogen has no family. It has a +1 charge, and it's the most abundant element in the universe. Not on Earth, but in the universe. Alkali metals. Alkali metals are the most reactive metals. The most reactive metals. They have a +1 charge, and they get more reactive as you move down the family. Now, alkali earth metals, group 2A or +2. They're very reactive. Neither group are found alone in nature, but alkali earth metals are very reactive, but not as reactive as the alkali metals. Okay, so reactive, but not as much as the alkali metals. Now, going across the periodic table, we come across the transition metals, also known as the B group elements. The boron family, group 3A, has a charge of +3. The carbon family, plus or minus 4, depending on if it's above the stair step or below the stair step. The nitrogen family, which nitrogen is the most abundant gas on Earth, comprises 78% of air. This is group 5A. It has a -3 charge. The oxygen group, a -2 charge. The halogen group is a -1 charge, and this is the most reactive non-metal group. Okay, you have to know the name of this. Now, something fascinating about the halogens are they're part of the Brinkelhoff twins. The Brinkelhoff twins. These are diatomic, di meaning two, atomic meaning atom, that exist as pairs. A way to remember this is they make a magic 7 on the periodic table, along with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, but don't forget hydrogen over here. You must memorize the Brinkelhoff twins. These are the 7 diatomic molecules that are never found alone in nature. They're only found in pairs. Last family that you need to worry about is the noble gas family. These are unreactive because they have a stable valence arrangement, meaning a full outer shell. These, neon through radon, have a full octet or full 8 valence electrons. Helium has 2, but it has a full outer shell. Okay, so here you were to color. So the alkali metals, the alkali earth metals, the transition metals, the inner transition metals, because they insert here, the boron group, the carbon group, the nitrogen group, the oxygen group, the halogens, the noble gases. You must know all of the names of the main group elements. Okay? So the alkali metals, the alkali earth metals, alkali metals being the most reactive metals, the alkali earth metals, the boron group, carbon group, nitrogen group, oxygen group, then the halogens, and then the noble gases. Okay, your periodic table should look just like mine, and you should know everything that I have written on here. If you have any questions, be sure to email me.